So we didn't copy the alternative solution. Okay, okay. You want to copy that? Okay, but you can write, right? You can try. You can try on your own, because now I have explained the alternative solution. Maybe you can write down that. Okay, right. Okay, now try to do this one quickly. Find the average of two numbers. You have to write a solution. Maybe you can use the same method. Find the average of two numbers. So write the solution. You know how to write. Remember we did in the last class. Okay. Yes. How do you what is the okay? You know the steps, right? We have to define three things: the input, the process, and the output. Okay. Shall we just check the answers? So what are the input? You can say the two numbers. Here I have assumed like in number one and number two. Maybe if you are writing like N, capital N, then you can use the capital N, right? Okay. What is the process? What is the process here? What is the process you have written? Very simple. Yeah, can someone, you can write, you can send the answers only for the process. I don't need input. No, it's very clear. So how about the process?
Add N1 and N2.
Yeah, better you send into the chat box, right? So we can see then if any problem. Add both numbers and divide it by 2. Yes, that's a good answer. And output is average. Add N1 and N2 and divide it by 2. Okay. Najat, yes, average is equal N1 plus N2. Yeah. That, yeah, Rida, right? Oh yeah. Yeah, either you can write it or you can send the formula. You can write the formula. Calculate the total. First you have to say, okay, here, all right. Now, when you write this one, you can write it in two steps. First, you can find the total. You can find the total, so you can add everything. Then you can go for the average. That is one method. Or if you can write it directly like average, as some of you have written, number 1 plus number 2 divide by 2. So this way also you can write. So if you want, you can take the number, you can find the number in the first step, then you can go to the average, or you can directly write the average, since because we want to find the average. Okay, either way it's okay. Finally, we know the output as what display the average, right? So you have to show the average. So that is the output. Right, at N1 and N2 divided by 2. Yeah, that's the process, right? Okay, fine. So this is how we write solutions for problems, right? Now, we will go into the next area, right? Okay, now let me okay, now we have to learn. Now we know how to write solutions for problems. Now we see uh, what is an algorithm now, right? What is an algorithm? It's very simple. Algorithm is very simple. It's just a term, right? So before that, let me show you this video, right? So maybe you can find the answer for this question. So what is an algorithm, right? Try to, okay, my question is this, right? So watch this video and try to find out what is an algorithm, okay? What is an algorithm? You have to tell me at the end of the video, what is an algorithm? Okay, listen carefully. Let me play the video. If you if the sound is not coming, just let me know, right?
You may have heard the term algorithm recently, whether it was online or maybe in some conversation about technology. It's a word that gets thrown around a lot, but what exactly does it mean? Well, simply put, an algorithm is a set of steps used to complete a specific task. They're the building blocks for programming, and they allow things like computers, smartphones, and websites to function and make decisions. But in addition to being used by technology, a lot of things we do on a daily basis are also similar to algorithms. Let's say you want to make some spaghetti. In order to do this successfully, there's a certain set of steps you need to follow in a particular order. First, you need to boil a pot of water. Once it's boiling, you then add the spaghetti and cook it for a set amount of time, stirring occasionally. Once it's finished, you drain the water and then it's ready to be served with a sauce of your choice. That entire process is actually an algorithm. Because you followed those steps in that order, you reached your desired outcome, a delicious pasta dish. But if you were to make a mistake, say over or undercooking your noodles, it probably wouldn't be as good. Programs work in a similar way. Their code is made up of algorithms telling them what to do. Let's say that we want to use a navigation app to get directions. When we punch in a destination, the app uses an algorithm to look at the various available routes. Next, it uses a different algorithm to check the current traffic. And then a third one takes that information and calculates the best available route. All of these algorithms are built right into the app's code. If there were any kind of error in that code, the app wouldn't be able to follow these algorithms correctly, meaning you wouldn't receive your directions. Both of these examples show how both humans and computers can use algorithms to perform everyday tasks. The difference is that computers can use algorithms and calculate things better, faster, and more efficiently than we can. Technology is only going to continue to evolve and get even better at what it does. As long as coding and programming continue to be used, algorithms will be at the heart of these technologies, guiding what they do and how they do it.
GCF Global, creating opportunities for a better life.
Okay, so what is an algorithm then? What is an algorithm then? Building unit of programming. Okay, building units of programming. Okay.
Method to show steps in solving a problem.
Steps, okay, to solve a problem. Instruction given to a process. Yeah, okay. Steps we do to get a proper output. Set of steps followed to solve a problem. Yeah, very good. Set of steps. Okay. So now, okay, now remember what we did before to solve a problem, right? We wrote So step-by-step procedure to solve a problem. So basically, this is what we did, right? For take a look at the example. So we want to find out the average of two numbers. What we did, we take the input, then we write the process, then we come up with the output. So algorithm in a simple term is like this. So when you have a problem, right, to solve the problem, you have to write down the steps. So this is, but there's a condition that you should write the steps in the order, right? That's why we start with the input, then we write the process, then we come up with the solution. Rather than start with the process, then you say the inputs are there. It's not like that. When it comes to the algorithm, right? Algorithm is a set step-by-step procedure to solve a problem. So you are explaining the solution in step by step. So that is basically algorithm, right? So you can note down this, the definition for an algorithm. You can write down what is an algorithm. Okay, note down that algorithm, introduction to algorithm, maybe definitions. You can say definitions. Algorithm is a method to show the steps in solving a problem, but that is one definition. So is this the first note for the? Yeah, Atika, you just joined. Yeah, that is the first note. So we did a exercise. Maybe that's a very simple one. Then this is the first note. Yes. The algorithm is a method to show the steps in solving a problem. Okay, an algorithm is write down everything, is a step-by-step procedure for solving a problem. These are different definitions. Okay, anyway, if you have an idea what is an algorithm, then you can match anything. So first one is algorithm is a method to show the steps in solving a problem. Algorithm is a step-by-step procedure for solving a problem. So basically everything like step-by-step, right? A process or set of rules to be followed in calculations or other problem solving operations, especially by a computer. This is the third one. So you can write down all three: the introduction to algorithms, the definitions. Definitions. Okay. Okay, now let's take an example. This is very, very simple one. Okay, if I ask you to develop an algorithm, you don't need to write down, just let's discuss this. To develop an algorithm to post a letter, how do you write an algorithm to post a letter? Yes, how do you write an algorithm now? So this is very, very close to the previous section, right? Very, very similar to that one, right? So here we have to write an algorithm to explain. Okay, this is how you write a letter and you post it. So how do you write that? Okay, if you look at this, right? We know initially you have to write the letter, right? Then you have to forward the letter. So look at this one. We are writing every steps clearly. As I said, remember this: whenever you write programs, you should remember this. The computer it's a dummy machine, right? The computers can't understand the instructions as we human, as we understood. So the third one, you insert the letter, then you write the address in the envelope, right? You insert the letter into the envelope, then stick the stamp. So this is how you write. Okay, now look at this one. Okay, now maybe in some step. Okay, if you write, look at this one. You don't need to write down this, right? Okay, if you say, okay, first for the letter, you start with this one. Then you say write the letter. Okay, fold the letter, write the letter. Okay, maybe then you can say post the letter, then you say insert the envelope, the letter into the envelope. Then what do you think? If you change these steps, will this algorithm work? No. Yes. So that is why we say algorithm is what? Algorithm is a step-by-step procedure, or step-by-step procedure for solving a problem, right? So it's a step-by-step, or you explain a method to show the steps involving in solving a problem. So the steps are very important, right? Steps are very important. Maybe in some places, maybe you can adjust. For example, here, maybe you can say you can change some places. Look at this one here. How do you change this? Maybe okay. Maybe you can change 4 and 5. No, stick the stamp, then write the address. You can interchange this. Yeah, that won't make any issue, any problem to this algorithm. But some steps you can't change, right? You can't change. You can't start with post the letter, then write the letter. So that's wrong. So that is important, right? See, this is an also when you write an algorithm, right? Normally, like, okay, let's do another example, a practical one. Okay, now shall we do this one? Write this one. Write an algorithm to find the perimeter of a circle. You know what is the perimeter of a circle, and you know how to find the perimeter, right? Okay, can you write an algorithm for this purpose? How do you write an algorithm now? Okay, since this is the first example, I will help you, right? Okay. Okay, how do you write a program, basically algorithm to find the perimeter? So perimeter of a circle. How do you? What is the basically what you have to do with the perimeter? What with this? Okay, let's say this is the radius R. So yes, can someone tell me? Let me name someone here. Yes, Huda, can you tell me how to find the perimeter of this circle? What is the formula? 2 pi r. Yes, 2 pi r. So r is the radius. So we should know the radius. So we have to measure the radius. Okay. Now, how do you write an algorithm? Right, same method as previous. We have written the solution. No. So first you write the input, right? Don't write this. Okay, what is the input in this case? What is the input here? Input is the radius of the circle, right? Radius of the circle. So you can write the radius of the circle. Yeah, radius. Let's say radius or radius of the circle. Then the process, you write the process. That is, we have to find out the perimeter using this formula. We can use this formula, that is 2 pi r, and we know we have to assume pi is equal to, what is the value of pi? What is the value of pi?
22/7.
Oh yeah, 3.14, right? Yeah, 22/7, right? 0.7, right? So then finally the output is the perimeter of the circle. So that is the output, right? Now, when you write an algorithm, so we don't, basically what you have to do is you just name these steps. This is the first step, this is the second step, maybe if there is something like then third, then the fourth. But we don't write like input, we don't insert these words, okay? But still we start like this. So first you have to write the input, then the process, then the output, but you don't write the words, okay? Let us see how to write this. Okay, first say, okay, see, This is why, because I have included this in the bracket, that means you don't need to say this is an input. When you write an algorithm, you say, okay, find the radius of the circle. That is the first step. You find the radius. Here, this, I mean, look at this one. Yeah, I'm not worrying about the method. So you have to know how to write an algorithm. So this is just an example. So don't, I mean, even if you don't know this formula, it's okay. Now you calculate the perimeter using 2 pi r, this formula. Or maybe you can say use the formula 2 pi r, whatever, right? That's okay. You can change the words. That's the process, but we don't write it. We don't write the process. I'm just, because I have included just to explain this, right? That's why I have included with the brackets. But you don't need to write that. Then the perimeter. Finally, the output is the perimeter. You can say, you can find the perimeter, or the output is perimeter. So this is how we write an algorithm. Okay. So here the steps should be important. We should follow steps 1, 2, 3. Okay. So now you can note down the answers. Okay. Right, as we discussed in the previous example, there are steps in algorithm which should be followed in strict order, right? But sometimes, some step, as I showed you in the previous example, maybe you can change, right? That won't affect the process, right? Okay, but some step you should follow in the strict order. Okay. Now, when you write algorithm, right? Okay. Can you write an algorithm to find the age of a person? So we know the birth date. So we want to find out the age of the person uh, on today. Okay, we know the birth year. We know the year of birth, or we say date of birth, whatever, right? We know this. So we have to find out the age of the person on today. As of today, we have to find. So write an algorithm. So can you guys try this? Yes, you can share the answers. You can put into the chat box. Is Kirtika is here? No. Right. Okay. Niruksha and Kirtika. Okay. First try to, okay, what is the process? I mean, how do you find out the age of a person when you know the date of birth? So think of that. How do you find out that? So what are the input now? What are the input? Today's date, okay. Find the DOB and okay, input. Don't write input. When you write algorithm, don't need to write input and this process. Just you can write the algorithm. Find the year he was born and the current year. Okay, that's one thing, right? Okay, find the date of. Then what is the next step? Today's date minus date of birth. Okay, then yeah, very good. Then you will end up in the age. Yes, that's the method. Yes, Salhan, but you don't say input. Yeah, you take the date of birth and the today's date and the process you subtract it. Yes, and yeah, you will end up in output. But no need to say this. Okay, just you can write the step. Outcome subtract the date of birth from the today's date. Yeah, but then you have to write the input as well. Okay. Subtract Zaharin, subtract today's date by the date of birth. Yes, subtract today's date by the date of birth. Yes, today's date minus date of birth. That's also correct. Yes, yes, right. Okay, now look at this one. How do you write this algorithm? So you can say you can input, you can take the year of birth and current year, right? Because we need both. Here, I mean, we are taking only the year. We are not, I mean, worrying about the date, right? Okay. Then you have to calculate the age by subtracting the current year. You know, right? When you have a, as some of you said, let's say the age is equal to today's date or current date or year here. Okay, I have used year minus date of birth. That is also correct. This is also correct, right? Then finally, we have okay. Now here we have the answer in years, so maybe convert the answers to years. Yes, because when you subtract it, you will end up with month. So here, no, okay. Find the date of birth of the person and today's date. Find, or we say Atika, you have to input, no, because already we know that, right? Because date of birth and the year of the today's date are known, right? So you can just ask them to input. Then you can calculate what you can calculate the age of the person by subtracting. Then display the age. In case, because when you subtract, you will end up in months. So maybe you have to convert it to years. Uzma, find the date of birth. Find the date of birth. Better we say just input the date of birth. Find today's date. Calculate date by using the formula. Okay. Yeah. Okay. Fine. Okay. Fine. All are right. Because the important thing here is the steps. You can't, if you say like, okay, you can, if you say like, subtract this one initially, subtract the age and the year, date of birth and the today's date, and then you say okay, input the, yeah, then it's wrong. So important thing is you have to follow the order. That's the important one. That's the important one, right? Isn't that should be subtracted year of birth from the current year? Yes, you should subtract. Okay, look at this one. Okay, now let's say let's take the date of birth, some date of birth. Let's say it's a what is the today's date? It's a 14th 14/6 and the year, okay, 2022. So if you want to find out the age, let's say somewhere around 2005, right? Let's take a date like maybe 04 and the month, let's say 02 February. So you have to subtract the today's date, right? This is today's date. This is date of birth, right? Is that correct? Maya, isn't that should be subtracted year of birth from the current year? No, you have to subtract other way, right? For the year of birth and the current year, date of, yeah. Then yeah, that's simple. Yes, you are also correct. Date of birth year minus. Right. So this is how you write an algorithm, right? Very simple. You write steps. Okay. If others you can't understand, you can just copy down, right? Maybe we will do some exercise later. We are going to do more exercises, so don't worry. Right. Now I think now if I ask you to write this one, sir, in your slides, it's the other way around. Calculate the age by subtracting the current year from year of birth. Yeah, that's wrong. You have to change it. Yes, thank you. Calculate the age by subtracting current year from year of birth. No, that should be other way. Yes, correct. This is wrong, right? So now you know, right? So you have to subtract from the date of birth the current year, right? Sorry, from other date. So today's date minus date of birth. This is correct. Right. Okay. Thank you. Now, okay. Now, can you write an algorithm to find the average of two numbers? We already written that, so we have the answers. That's why that's the first one. So now, if I ask you to write an algorithm to find the average of two numbers, how do you write that algorithm? How do you write the algorithm now? Now, the same thing. Remember, we did. Now we say input two numbers. We don't say my input is this, but we say okay, enter two numbers through the keyboard or whatever. So right, like that. Previous one also we say okay, input the date of birth and the date, today's date. So you can say input, because you don't say find out the date of birth, because date of birth is already known. So and today's date. Today's date, you say input this. Today's date, you can ask the user to input this, because these are very clear. You don't need to find out, you don't need to write anything, right? So you just say input, right? So like that, here we ask the user to input the numbers which you want to find out the averages. Like when you go to the ATM, right? So if you look at, if you notice the ATM, so you will get a message like input the or enter the pin numbers, right? Enter the pin number. So we have to enter the pin number. So nothing to find out anything, right? So input two numbers. So we already did this. Then you calculate the total by adding both numbers. Here, look at this one. We are not saying the process. That's the only difference. Finally, find the average. You have to divide it by 2. So now you will end up in the average. So you display the average. The same thing, but we don't write the terms like process, output, inputs, right? So this is how you write an algorithm. Okay, the step by step the process. Is that clear? So any questions from what we have discussed so far? Any doubts? If you don't understand anything, let me know. Right, now we will move to the next part. Okay, so when we build or when we construct an algorithm, right? Not always, we have, I mean, like, okay, not always we have like very straightforward algorithm, because sometimes, okay, okay, like the previous ones, okay, it's a very straightforward one. We say it's a sequence one, right? Sequence, step by step, or like the posting a letter. So it's a step by step. But let's say, okay, if I ask you to write an algorithm to find out the largest number, or let's say, if I ask you to find out the minimum marks from, let's say, for example, a set of marks. Let's say we have 2 marks, right? Marks 1 and marks 2. Okay, now if I ask you to find out the minimum marks, what you have to do is, right, we have to say if one marks is greater than other. So here we have a condition. So we say, so if the condition is okay, if it is satisfied only, we say okay, minimum is this. Otherwise, we don't take that. Like that, there are some algorithms where you have to use this branching. We say the condition statement or the selection statement. We'll come to that. There are some algorithms you have to repeat again and again, right? For example, let's say you want to write an algorithm to mark the attendance. Remember that? So how do you mark the attendance? First, teacher like start with the first student. Okay, first teacher has to go through the list of names. So start with the first student, call the name, okay, absent or present or absent, or if it is present, okay, put a right. Then same thing, second student, do the same thing. Third student, okay, call the name, okay, if present, put a mark, not, if not, put a cross. So the same thing she has to repeat until she comes to the last one, let's say the 30th one. So this is called the repetition, so repeating one, okay. So we say when we write an algorithm, we have to use the control structures where you can control the flow of the algorithm, okay. So we have three type of control structures. We'll quickly go through this. Anyway, we're going to use these control structures throughout this course, right? Throughout this course, even with the Pascal programming, we are going to use these control structures. So write down this control structures. So we will see some examples. So don't worry. So you will be, I mean, anyway, you will be all right after we finish this. So control structures, and any algorithm can be constructed by using three different flow control structures. Any algorithm can be constructed by using three different flow control structures. First one is sequence. We say sequence means step by step. So order is important, right? Then second one is selection. There are sometimes we call that condition statements or branching statement. All are same. Third one is repetition. Third one is repetition. Or there's another name called iteration, iteration or looping, right? Iteration or looping, repeating, iterating or looping. Okay, we'll come to this one, sequential one, right? So now let's take this example. Let's take this example where you plant a tree. These days, very popular thing, right? So everyone try to plant something now. After all, so now so we don't have any other choice now, right? Okay. So look at the steps. When you before you plant, right? Plant a tree. So we know, right? Let's go by one. First, you have to get the flower pot. Let's say we want to plant flower, right? Then you have to put the soil, okay? Then put the seeds in the flower pot with the soil. Then water the seeds, right? Then put the flower pot in the sunlight. So finally, you will end up with this nice looking flowers. Okay, now here, look at this one. So we say this is a sequence structure. So why do we say it's a sequence one? Why do we say this is a sequence one? Yes, anyone? Why do you say this is a sequence one?
It occurs step by step.
Yes, it goes step by step. Very good. We do it in order. That's also step by step. Yes, good. So if you if you change, if you start with the fourth one, then you go to the first one. You first you put the water into the pot, then you just take the flower pot. Then that's wrong, right? So here you should follow the order. Yes, it occurs one after another, and the order is important. Okay, instructions are executed one after other, and also you have to follow the instruction in order. So maybe you can note down with the sequence one. Sequence is the default control structure. That's the basic one. Here the instructions are executed one after another. Right? You don't need to write down. If you want, you can draw this, but you can just write as an example here, right? Maybe you can say planting of flower. Okay, whatever. Planting a tree or flower. Right. So that is example. That is one example. Even you can say posting a letter. So that's another example to show the sequence structure, right? Sequence one. So here the instructions are executed in one after another. Okay. Next one. Right. Okay. We'll take another example. Add two numbers and display the total. Very simple one. Add two numbers and display the total. Okay, now look at this one. You don't need to write down this. Maybe you know, right? So we take two numbers here, add them together, and you get the total. Look at this one. Can you change the? You can't change the steps here. This is sequence one, right? So basic one is sequence. Okay, the basic one. Okay, now let's take a control structure. The control one. So now let's take this example. If a Sri Lankan citizen gets the right to vote after completing the age of 18. So if you are like 18 plus, you can vote, right? So you can select someone like Gota. So that's a good thing, no? So select the most suitable word for blanks. Okay, now look at this one. If the age is, now what you say, if the age is more than 80 only, they can vote. They can cast the vote. They can vote. If not, they can't vote. Now look at this one. The important part is if they can't vote. Now this is the important one. The selection one. Selection. So there's always a condition to check. There's always condition to check. So let's say if the temperature is greater than 32, for example, right? Let's say if the temperature is greater than 32, then you switch on the fan. So we can say we have to switch on the fan. Or if not, else, if not, oh no, we'll write if not, that means switch on the fan. If not, the temperature is below 32, we say we don't need the fan. So maybe we say you can switch off the fan. So this is a selection statement. Look at this one. So this is why. So this is where these type of statements we say the selections or conditions, right? So there is a condition to decide. Is that clear? So we know the sequence. Which when you go back to the sequence one, there's no condition. So it's just a sequence one. You just plant the tree. There's no condition. Okay. Is that clear? So you don't need to write this one. If you want, you can note down as an example. I think it's very simple, right? Okay, next one. Selection. Let's take this one. As I said, okay, finding the largest number. Remember this one we did, right? We take two numbers. Then if the numbers one is greater than number two, we say number one will be larger than otherwise number will be n1. Okay, large number will be n1. Okay, now look at this one. Here also we have this selection. So this is called the conditions. Okay, condition or the selection structures. Selection structures. Okay, is that clear? Okay, finally, third one, the repetition, as I said. Okay, now here, I'll go back to the same example, the class teacher marking the attendance. Now look at this one. Okay, look at these steps. First, she has to call the first name on the register, the first student's name, right? Then mark one or maybe mark, put a tick if the student is present. Otherwise, put zero. If not, put zero if the student is absent. Okay. Now, what happened? After third step, look at this one. After third step, now call the second student. This is second student, for example. Next student, basically, the next student. Now what happens? Okay, after calling the calling the name of the next student, she has to she has to repeat. She has to, okay, now after calling this name, she has to do the second step. She has to do, right, mark one if the student is present. Then she has to repeat the second and third. Now repeat these steps. Can you understand here? Is that clear? Okay, so this is called the loops or looping or repetition or what, iterations. This is iterations. You iterate in a circle, like, right? So you have to repeat this. So next, go to the third student. Mark, call the first name of the third. So sorry, you call the third student, then mark if the student is present, or mark zero if the student is absent. So next student. So you have to repeat until you reach the last student. Until you reach the last student, you have to repeat. So these type of structures are called the repetitions. Is that clear? That is repetition or the iterations or the loops, right? So maybe if you want, you can write down as an example for repetition. Okay, now can you guys come up with an example for repetition structures? Okay, you can send the answers in the chat box. Multiple of 3 between 10 and 100. Multiple of 3 between 10 and 100. How do you say it's a repetition? Multiple of 3 between 100, 10 and 100. Okay, let's take a multiple of 3. Okay, between 10 and 100. Yes, who said this? Right. Okay, between 10 and 100. No. So what are the numbers you have? Like 12, 15, 18, right? It goes on, right? Yes, now how do you say it's a repetition? Finding the area of 3 squares. That's a good idea. Finding the area of a, okay, good example. Okay, we want to find the area of 1 square. Then, okay, you know how to find out the area of 1 square? Like you have to multiply the width and the height or width. Then, yeah, you have to repeat it for a 3. Yeah, that's a good answer. Okay, that's correct. Select some numbers and find out whether it's smaller than, okay, 10. Keeps repeating until the last number. Yeah, that's okay. That's okay. Maybe you have to say, yeah, okay, maybe less than 100. Okay, you have to repeat it. Yeah, you have to repeat the same. That's good idea. Yes. Yeah, when you have like, okay, that's a good example. Let's say we want to find out the smallest number between 1 to 20. Oh, right, okay. Yeah, so these are some repetitions. Is there anything else? Select some numbers and find out whether, okay, that's okay. Finding the printing papers or books. Yes, okay, you are repeating. Okay, good. In washing clothes, we follow the same step until then. Yes. But is it a repetition? Are we doing the same thing? Maybe you, but in a washing machine, if you are using a washing machine, because in a washing machine, you have, because we are using it once, right? Okay, paper marking, paper marking. Okay, so yeah, you're repeating the same thing, but with the Hamdi, with the paper marking, there's a problem because we are not like we are not because when you mark the paper, okay, you take the first student's paper, okay, you mark it, then yeah, that's correct. Yeah, that's okay because you are following the scheme. No, you're following the marking scheme. Okay, paper marking. That's another repetition. Okay. Anything else, Salman? So you can just think of a repetition. Hand washing, yes. If hand washing, you have to repeat. Yes. Memorizing a poem. How do you say memorizing a poem? Hmm? Maybe okay. Let's see whether I have another example. Right. Okay. Okay. Process of reading a paragraph and calculating the number of words you read. Right. Okay. Okay. Maybe look at this one. So you have to calculate the number of words in a paragraph. So let's take this is one paragraph. Why I went to Candy, right? So this is one sentence. No, so you have to count the number of words in a paragraph. I went to Candy to, let's say, bring a bottle of brandy. No, let's say something else. No, okay. To bring something. So okay. Now, if you want to count this, right? So you have to count the words in the first line. Okay, count the words. How many words are here? 4. You go to the second one, count the words 3. So you repeat it until you reach the last line, until you reach the last line. So this is called the repetition. Is that clear? Okay. Is that clear? Right. So that is repetition. Okay. Read the first word, then number of words. Okay. I don't know. Right. Now, can you do this small activity? Can you do this one? So you have to identify. Right. Look at this one. You have to say there are 3 letters, right? A for sequence, B for selection, and C for repetition. Okay, go through this and see. Okay, first one, if it is a repetition, you can write C. Or if it is a sequence, you can say A. Like that, you have to write it. So you can write down the answers in your book. Say 1, for example, A, 2, B. Like that. Read the sentence and see whether you can correctly identify the control structure in this used in this example. Okay, first one. Add sugar to a tea while the taste is not good enough. You are tasting the tea. If the taste is not enough, you have to add sugar. If not, you don't add. Okay. What type of structure is this? Atika correct. First one, Zaharin correct. Sorry, Atika wrong. Atika not wrong. No. It's no, Atika correct. Interesting one. Zaharin wrong. Okay. Sara correct. Hamdi correct. Right. Salhan, Shihan correct. Najat correct. Najat, then Murshid, yes, good, correct. Yes, Mayada correct. Arkam wrong. Now we have a confusion, right? We have a confusion. We know it's not a sequence one. So whether now we should decide whether it's a repetition or a selection. That's the problem, right? So that's the problem. Zaharin, Fadila wrong. Zaharin also wrong. Arkam wrong. Umar correct. Yes, Samiha wrong. Right wrong. Fadila right. What is this? First one, I need the answer for the first one. Fadila, okay, correct. Okay, now look at this one. First one, you okay? Yes, there's a selection, correct. So you taste the tea. If the taste is not enough, I mean it's not enough. Sugar is not enough. You have to add sugar. Okay, so it looks like a selection, but look at this one. Okay, now once you add the sugar, again you have to taste the tea. Okay, again taste the tea. If still sugar is not enough, you have to add sugar. You have to continue that till you come to a satisfactory level. So if you are satisfied with the sugar level, then you can stop. That's how you taste the tea, right? So if you know that first one, Shihan, first one, so that is a repetition. So you have to repeat the same thing. Add the sugar, taste it. If the taste, there's a condition that yeah, there's a selection, but this is not just a selection, it's selection plus C. So right answer, the correct answer is B and C. Is that clear? So I think no one sent this answer. First one, it's both. Yes, can you understand? So it should be the both. It should be both because initially you test. Okay, if the condition is there, selection is there, but you have to repeat. Is that clear? Find the area by taking the radius of a circle. Okay, what type of structure? Second one. Yes, ABC. Mayada ABC. You can tell just type ABC. Yes, it's a simple one. It's sequence because finding the area finding the area by taking the radius of a circle means so you just find the area. There's no condition, no repetition. Okay, that's a simple one. Third one, the mother feeds the baby until the baby is full. Okay, what type of a now you have to, this is very simple. Third one, yes, Zaharin correct, Sihan correct, Samiha correct, Atika. Oh, is that B and C or just the C? Mayada wrong. Mayada, the third one. Najat, B and C or just the C? Yeah, we say it's just a C, right? It's just a repetition. She has to repeat it, right? Until, there's no way, if the baby is full, then stop it. Okay. Maybe, okay, we say it's a repetition. Okay. Fourth one, choosing the tallest person out of two. Choosing the tallest. There are two persons. You have to choose the tallest one. Fourth one. Fourth one. Yes, it's a selection. B. Fourth one is a selection. Last one. Last one. I can't read that. Why is that? Last one, selecting or rejecting an applicant during an interview. Yes, Omar, why do you say it's a selection and repetition? Selecting and rejecting an applicant, one applicant. So that's, yes, that's a selection. So see, this is not, you're not saying selecting and rejecting all the applicants. You're not repeating the process, because this you have to apply only one. So an applicant during an interview, that is B. That is again B. So hope this is clear, right? So now you can identify the structures, right? You know how to identify the structures. Okay, so now that's all we have. So I'm going to stop here today. So we are done with the algorithm part. Hope the algorithm part is clear to you all. Okay, am I right? If you have any question on algorithm, I mean, we are going to continue anyway. So we will continue flow charts. Now, you know, now the thing is, okay, now if you come back to this algorithm, right? So this is, no, not this one. If we take this one, okay. Now, look at this one. Now we have a question. Now, how do we represent this algorithm in computer? I mean, or we say in software engineering field, because there should be a standard way to represent. Because otherwise, everyone will, I mean, write, or they will come up with their own way of writing these algorithms, right? So you can't say it's wrong. So what happened? The people who are involved in the software engineering, we say it's an engineering, right? It's a process. It's an engineering field, right? They standardize this algorithm. So they have come up with two methods to represent algorithm. To represent algorithms, right? So the software engineers introduced two methods. So everyone should follow that. So when you work in a real-time project, when you work in a company, or when you do any, like, let's say you are writing a computer program, so you can represent algorithm using graphical method. In a graphical method, if you like, you can use a graphical way using some symbols, or you can use the text as we have used here. But that should be a standard method, right? Because otherwise, everyone will use their own way of describing this. You can't do that. So they have standardized this. One way is graphical method, that is called the flow charts. Is called this as flow charts. So we have some symbols. Okay, if you want to say an input, for example, so you have to use a parallelogram symbol. So if you want to say a process, you have to use a rectangle. So there are symbols. They have introduced symbols. So everyone should use that symbol in order to represent an algorithm. So remember this. Why do we use this? To represent the algorithm in a graphical way, we use the flowchart. Or if you want, you write a pseudocode. We say a pseudocode. Pseudocode. This is again a standard method to write the algorithm. So basically what we are doing here is we are representing the algorithm in either using a graphical method or a text-based. So text-based method is called the pseudocode, and the graphical-based method is flowchart. But if you take if you take this Pascal or the programming question, right, 90% or maybe 95% of the questions, right? Let's say if you are having like 4 questions in the in O level, like almost three comes from flowchart, either from flowchart or pseudocode. Sometimes combining both. So the next steps, next classes, coming classes are very important. The flowchart and the pseudocode classes are very important. Don't miss that. So what we have learned is like 5% for the exam so far. But what we are going to learn is the 90% of this Pascal or the programming question. Is that clear? So what we are going to learn is very important. So we'll see how to build pro charts and how to write pseudocodes in coming classes. So I will stop here. So if you have any questions, you can ask now.